Hi everybody, today we're going to be taking notes over our third method for solving quadratics. And before we can do so, we're going to review how we would solve using square roots, the last method we learned, because it's going to be important to being able to complete the square. So here in example 1, review problem 1, we are ready to square root both sides, which leaves us with x minus 2 equals plus or minus. Now because this is negative, we're going to make it positive and add a 4. Then the square root of 16, or add an I, and the square root of 16 is 4. So we have plus or minus 4i. Then we can write our two equations. X minus 2 is 4i. X minus 2 is negative 4i. When we add the 2, we get x equals 2 plus 4i. And we get x equals 2 minus 4i. Okay, then over here, number 2, first we divide away that 3. Goodness gracious. That leaves me with x plus 5 squared is 8. Then we square root both sides and we get x plus 5 is plus or minus. Now to simplify the square root of 8, we get square root of 4 and 2. So 2 radical 2. So then we still write our two equations. X plus 5 is 2 radical 2. We subtract our 5. X is negative 5 plus 2 radical 2. Then we have to do the negative case. X plus 5 is negative 2 radical 2. So x is negative 5 minus 2 radical 2. Okay, then for number 3, we do it just like we did this last one. We divide first. That leaves x plus 3 squared is 25. Oh good, this one's pretty easy. When I square root both sides, I get x plus 3 equals plus or minus. This one's just 5. So then I set up my two equations. X plus 3 is positive 5. Which gets me 2, and x plus 3 is negative 5, which gets me negative 8. Okay, so now we're going to talk about how we actually find the square, how we complete the square to solve. And so the first thing we need to do is find a C value that allows us to have a perfect square trinomial, which means we can write it as one set of parentheses squared, a binomial squared. To find this C, we take half of the B value and then square it. So for example here, we have 12 as our B value. So remember C equals B over 2 squared. Half of the B value, so 12 over 2 squared is 6 squared, which is 36. Okay, then we can factor this. Remember, we'll say x and x gets us x squared. And then in order for them to add to 12 and multiply to 36, we're going to have 6 and 6. That's what you'll find is that this number, this second number, is whatever you had in this parentheses before you squared it. Then our signs are positive so that they multiply to positive 36 and add to positive 12. So this is x plus 6 squared. Okay. Here we do negative 3 over 2 squared. Well, negative 3 over 2 is negative 1.5. Okay, but we're going to keep this as a fraction. So when it's a fraction, we just multiply it by itself. Negative 3 over 2 times negative 3 over 2 would be 9 over 4. So now to get that, we have x and x squared. And then to get 9 over 4, we do that 3 over 2 and 3 over 2. We just figure out what is this number inside the parentheses. Okay, 3 over 2 times 3 over 2 will get us the positive 9/4. And negative 3 halves minus another 3 halves gets us this negative 3x. So this guy would be x minus 3 halves. Here our b value is negative 6. Negative 6 over 2 is negative 3. So that's 9. So then to factor it, we have x and x. Okay, then we take this number, or if you just want to try and factor, what multiplies to negative 6 and adds to, adds to negative 6 and multiplies to 9 would be minus 3 minus 3. So x minus 3 squared. Okay, so now let's practice actually solving by completing the square. Your first step in order to solve is to make space for that c that we just learned how to find. So we add our current c over to the other side, which leaves a blank there. Then we have 1 on the other side, but if we add something to one side, we have to make space for it on the other. Now we want to solve for that c value, so we take our b4 over 2 squared. That'll be 2 squared, which is 4. So now I put that into my blanks, 4 and 4. Now I have what can be written as a perfect square trinomial. If I factor this left-hand side, I know it's equal to 5, but I can write this as x times x to get x squared, 2 and 2 to get 4. They both have to be plus. So now I can rewrite this as x plus 2 squared is 5. This is something that we can solve by taking the square root. Right? Doing so gets us x plus 2 equals plus or minus the square root of 5. We can't simplify that. So then what we need to do is subtract our 2, or set up our 2 equations. It's positive radical 5. So we have negative 2 plus radical 5 and negative radical 5. So we have negative 2 minus radical 5. Okay, those are your final answers. Right there. Okay, I'm going to scoot this over so I give myself a little more space. Okay, on this guy, remember, first step, make way for your perfect c. So we subtract our 12x, or just our 12. We have 6x. This is where we add our blanks. We have negative 12 plus that blank. Now c equals b, so 6 over 2 squared is 9. So we fill 9 into both of our blanks. Now we can factor. We know we're going to have x and x. Negative 12 and 9 is negative 3. Okay. In order to multiply to 9 and add to 6, we need plus 3 and plus 3. So we can write this as x plus 3 squared is negative 3. Now we can solve by taking the square root. Okay, doing so gets me x plus 3 equals plus or minus. Now I can't take the square root of 3. I can't simplify that, but I need to pull out the I to make that 3 positive. So now I have x plus 3 is positive I radical 3. So x is negative 3 plus I radical 3. And I have x plus 3 is negative I radical 3. So that gives me x is negative 3 minus I radical 3. Let's see if I can make some more space here. Yikes. Okay. Now this guy over here, number 3, it already has its c value on the right hand side. So we are already good to go to add those blanks. So then C equals B, so 10 over 2 squared will be 5 squared, which is 25. Now we can factor this. We know we're going to get x and x to get x squared. And then plus 5. So x plus 5 squared is 28. Now we can solve by taking the square root, which gets us x plus 5 equals plus or minus. Now the perfect square that goes into 28 is 4. So we get 2 radical 7. Okay, now when we write our equations, x plus 5 is positive 2 radical 7. So negative 5 plus 2 radical 7 is one solution. And then x plus 5 equals negative 2 radical 7. Is my other solution. 1 and 2. Okay, we are going to actually end up skipping 5. So it's okay if you wrote in that space. Now number 4 is unique. Notice that number 4 starts out with a number 5, not just plain old x squared. And what we're told to do is pull out our GCF. So we're going to divide everything by our greatest common factor of 5. Okay? When we do so, we're left with x squared minus 2x plus 6 is 0. And now that's something we can solve. If I subtract my 6 to the other side, I get a blank. Now you might be saying, why didn't we leave the 5 out in front? Well, in this case, it's not that important. With factoring, it's important, but in this case, it's not because it would cancel out in the end anyway. So now C equals B, which is negative 2 over 2 squared. So negative 1 squared is 1. Then I factor so that I can write it squared. Because I pulled out my GCF, I have x and x. To get 1, I have to have 1 and 1. But in order for them to add to negative 2x, they both have to be negative 1s. Now I can write this. X minus 1 squared is negative 5. Then I can solve by square roots. X minus 1 is plus or minus. To make that positive, we have an I radical 5. So x minus 1 is positive I radical 5. And x minus 1 is negative I radical 5. Okay. Now let's recall the types of solutions we can get. In number 1, we had no I in our answer and we got 2 solutions. So those are 2 real solutions that would have 2 intercepts. Number 2, both of our solutions had an I. Both of them were imaginary. So those guys are 2 imaginary solutions, so that would have no intercepts. 3, no imaginary, so 2 intercepts, 2 real solutions. And 4, both imaginary, so 2 imaginary solutions means no intercepts. Okay, see what you can do here. 1, 2, 3. My tip for 3 is to look for that GCF. Okay, follow exactly what I did on the steps. If you need to go back and rewatch some examples, go for it. Okay, we'll go over these exit tickets tomorrow when you're in class.